Now, the next thing which I want to talk to you about is the use of static. What is the static keyword? What does it mean? Why do we ever use it? All of that. So to show you that, let me create you a new class called, let's say, static. And here, I would just want to actually copy this entire class definition of attendance and paste it out over here. Now, in our main of this class, I want to make sure that every time an object is created of this attendance class, the student count increments. Now, let's consider we try to do that over here. So, as before, let's create an object of attendance Java equal to new attendance, and this would be the first one, and the class name is Java. Now, again, if you want to do this, then we would just write 2 out here, and then this is how we have to manually do it. We could also actually have created an integer count equal to 0, and then every time an object is created, we could have put count plus plus into this, and then again count plus plus over here. But now, as you can see, every time I'm creating an object, I have to manually write count plus plus over here. Why not to have a mechanism in which my count of the particular class gets incremented automatically as many objects I create. So let's say the student 1 enters, and here count plus plus happens, then student 2 enters, and then again the count plus plus happens. This should happen automatically. So for that, what I would want to do is that I want to make the student count static. Now, what is the meaning of static? Static means that this student count is common to all the objects of attendance class. So static is all the common variables or methods for all the instances or objects. So instances and objects, both are the same, right? So what happens is that this student count is going to be the same for all the objects. So let's say, for example, student 1 enters. Okay, so now the student 1 sees that I'm the only person in the class. When student 2 enters, the student 2 knows that I'm the second person in the class. There are total 2 students in the class. Even student 1 can see that now total students are 2, right? That is the behavior which we want to implement using the static keyword, that all the students know who came before or who came later on, what is the latest student count. That is the use of static keyword. The static keyword is used to make sure that this student count is actually associated with the class. So static is always associated with the class and not with specific objects. Now, what about this class name? Class name is not static, okay? So any non-static variable is associated with each object. So now this class name is associated with each object. Okay, so let's say, for example, there is a student 3 who wants to enter but not in the Java class, in another class. So we can simply allocate the class name differently, right? Because for that student, the class is different, and for student 1 and student 2, the class is different. So everything which is non-static in a class, that is associated with each instance. Okay, now let's say, for example, we create a student 3, and here we would just pass in the class, and this is going to be, let's say, data structures. Okay, for student 3, the class is data structures, but student 1 and student 2, the class is Java. Now we did not want to do this manually, right? So I would just remove this from here, and we want to make sure that every time a new object of, so right now let's consider the case of only one type of class, okay? And what I want is that every time this new object of attendance is created, I want that the student count should increment. So that is going to happen over here, because every time we just initialize using the class name, I want the student count to increment. So student count would become 1 if it is 0. So here we define that the student count is 0 in the initializer block, right? So this is going to become 1. Now remember that for static variables, even if we do not initialize it to be 0, they are always initialized to be 0. So static members are always initialized to be 0. Now, every time we create a new object, this student count is going to increment. Now let's try to print this. Remember that static variables are always associated with the class. So I could have written student1 dot student count and then print it. Now here our output is coming 1, and the reason for that is this initializer block, right? So let me just comment this out, and instead of that, let's just initialize it to 0 out here, just in case this thing doesn't work. So when we try to print this, now as you can see that even though I am accessing it from student1 dot student count, and the student count initially was 0, when student1 was created, it actually got incremented over here. So it should be 1 logically, but then just because it is static, when student 2 came and student 2 actually made it to be 2, it is visible to student 1 as well. So when I try to access it using student 1, it is coming to, again, with student 2, if I try to access it, it will be the same, because it really is not associated with specific objects, it's associated with the class. And just because it is associated with the class, we don't really need to specify any object name. We can simply specify the class name over here. I would write the class dot student count, and then just print this, and again I would have what I want. So really this doesn't work specific to students. Now if you see this code, you would feel that there is some issue in this code, and even the IDE is telling you this. See, what it is saying is that the static field student count should be accessed in a static way, and here we have accessed it using this pointer. Now remember, this pointer is always associated with an instance, so we don't need this pointer over here. We can simply use student count, and since this student count and this student count is really not making any sense, so let's just change this count over here. So this is how we could use this. Again, over here as well, it's saying the same thing. Let's just remove this dot student count, and now a dot student count, again with a dot student count, it is giving the same warning over here. We don't really need student count to be accessed from an instance, but just because we are passing an instance to copy, so let's just leave it as it is, because otherwise if I just remove this again, it won't make sense, student count equal to student count. So let's just use that. But the whole point is that static members are not associated with objects, so better to just call them by class. So now it really makes sense, because right now the attendance is how much? 2. So we can simply call attendance dot student count. That's it. We don't need to actually ask any student, okay, student 1, how much attendance can you see in the class, or student 2, how much attendance can you see in the class. Just by looking at the, let's say, attendance register, we can say that oh yes, attendance dot student count is 2 right now. So this is how we can keep creating a new object of the Java class, and every time the student count will increment automatically just as we create. So in fact, if I just create a student 3, let's say, entering a class without even mentioning the class name. So just because a new object is created over here, we would again try to do a plus plus out here, and then when we print that, again the student count is 3, just because we made sure that the default constructor also increments the student count every time. So this is how we use static to make sure that we have a parameter which is not explicit to a particular object or instance. It is something which is associated with each class. Now similar to variables, we can have static methods as well. So this variable student count is static we can create another method. So let me just remove this initializer block from here, and we can create another method which is static. So let's create a public static attendance count, or let's call it get attendance count. Okay, now this method is static, meaning that this method is associated with the class. The objects are not going to get a copy of this method, it's just only available with the class. Okay, now this get attendance count will return the integer which is going to denote the attendance count of this particular class, let's say, and let's return this student count from this. Okay, so let's save this. Now instead of using attendance dot student count, we can use attendance dot get attendance count, and that's really going to give us the same thing. And now you can see that it is 3 again. But the main point of understanding the static method is that static methods can only access static variables. If I try to access class name, let's say, and I want to return class name, and let me just change the return type as well and try to run this. This is giving me an error right here, and it says clearly cannot make a static reference to a non-static field class name. Now what it says is that class name is not static, meaning that class name is associated with every object which we create. For student 1 the class name may be different, for student 2 the class name may be different, for student 3 the class name may be different. What I'm doing is that I'm creating a static method and I'm trying to access class name as if class name is associated with this attendance class instead of its objects student 1, student 2, and student 3. So it's saying that no, this is not common, this is not static. I cannot just return something from myself, because I can be called by just the class name attendance dot get attendance count, and I cannot just return a common class name because it is not common, it is not static. So really always make sure that you do not land into this trouble. Obviously your IDE is definitely going to help you in that, and just make sure that every time you are creating a static method and accessing static variables as well in this. Now main is always static just because the compiler has to make sure that the compiler can simply use the main which is associated with this class static, and that's why we also name is static.java, so that it's able to run this. So main is not dependent on any object which we create of static, and then through that object we are calling main. No, we can just call main using the static class, and then we can just call main. So that's how the compiler works, and that's why main is always static. Now remember, if main has to call some other method, since main is static, the other method also has to be static. Or so remember that every method which is calling another method has to be static. So if we just want to, instead of return student count, if we do this, we would return get student count, and I try to save this. Now it is giving me a red error, and it's saying the same thing, cannot make a static reference to a non-static method get student count. Why? Because this get student count, even though it is referring to a static variable, we have not declared this to be static. So what it is saying is that, see, I'm static, I'm associated with the class. You cannot let me call another method which is associated to various instances instead of the class. So I cannot just go and call something which is not common, which is not static. Okay, so don't do this mistake. Always let's make references to static only from a static context. So that's it about static, and you will really find good use of static keywords, good use of static variables and static methods in your Java programming journey.